All right, we have a couple minutes here, so try to get rid of the nervous energy. I do not speak for a living, so this is I do this for the challenge and for the opportunity to kind of expose myself to a little bit more of this type of thing. Um, let's see. I think we can go ahead and get started. So, just a couple of things, just a little bit about me. My name is Scott Arveseth. I put a QR code up here. It's not to hack your phones, but it's there to provide my LinkedIn profile if you want to know more about me. I'm not going to go into it here, but that just gives you a little bit about my career experience. So, a couple of things is when I was putting this together, I thought, oh yeah, 25 minutes, I can cover the cloud really well in 25 minutes. And as I started to get into it, I'm like, I need to add this, I need to add this, I need to add this. And the cloud is so incredibly nuanced. And so there's so many different ways to do things that I ended up just taking a whole bunch of slides out. I'm still taking slides out this morning because I'm worrying about getting it done in the 25 minutes. So I took the title, the inspiration for the title is based on a Rolling Stones song. One thing about the cloud, when you're moving into the cloud, I guess, or any environment, right? You get a little bit tired maybe at times, and maybe you kind of take back and you relax, and then like the lyric says, you wake up in the morning and you got parking tickets all over your cloud, or issues you got to deal with. And I think that's definitely the same as in the cloud as anywhere else. So. At the outset, let me just say too that I'm an AWS fan. I've been inside of AWS for probably close to a decade now. And if I had to choose between being in the cloud or a data center, I think I would definitely choose the cloud, because the cloud gives you a lot of things like resiliency, a lot of tracking, like actions that occur in your environment. It gives you awesome tooling as well out of the box. So I'm not trying to do a dig. I'm intentionally not trying to dig on any cloud providers or anything like that. So I just need to say that out at the outset. Kind of going back to my early days, I worked in a company that did bulletin board software. For those of you who know, that was phones and dial-up and modems and all that sort of stuff. And you used to have this very simple perimeter, right? You had the network perimeter, and you had firewalls around that, and of course you had behind that you had VLANs and everything else like that. It was a nice, simple perimeter, though, I like to say. And then along came cloud service providers, and let's just say the perimeters changed. Like I said, the cloud environments are full of nuances. They're full of different ways you can do things, and so I'm not going to give you the best advice here, but I'll give you some advice from my experiences. So, going beyond from the simple network perimeter, I like to kind of think about different cloud perimeters. And I've kind of got four main ones, and I guess you could say these applied previously, but I think they apply more even now. You've got your typical network perimeter, and that's basically the IP addresses that can reach your cloud services or your cloud accounts and all those sorts of things. They have VPCs, they have services, they have resource policies, all those types of things that go to that network perimeter. The other important, probably the most important perimeter, or one of the most important perimeters, is the permissions perimeters. That's the ability for people to act or have permissions to act within your cloud. And we're talking about things like people, organizations, the services that run in your account, the deployment pipelines that run in your account. Basically, we want to allow those trusted entities, and we want to block untrusted entities. And I think the other thing that the other perimeter we have in the cloud is the resources perimeters, and these are the resources that can exist in your cloud. In AWS, you can have things that have their own resource policies applied that are totally independent of your IAM permissions. And so you kind of have to look at your resource perimeter there. So you can have resource policies that grant public access or grant access to untrusted entities and those types of things. And so that's definitely a perimeter. And then lastly, I kind of like to think of the data perimeter, and this one kind of envelops all of the other three. But this one is a focus of what's your critical data and what do you have to protect your critical data, combining all of those things from your network, your permissions, and your resource perimeters, and they kind of all fit into that. So network perimeter, nothing new here. We have VPCs, we have services, It's a little bit more diverse than you have in your environment. With AWS services, we talked about resource policies can grant access to your cloud environment. Outside of your network policies, you have certain resources that are not attached to your VPC. We'll talk about a few of those. And all of these things are part of your network perimeter. So again, the main point is the network perimeter is a little bit more diverse than it was previously. So I think everybody's familiar with your VPC perimeters when we're talking about AWS. You have internet-facing resources. Those are usually put into public subnets. And then you have things that are put into private subnets that are not necessarily internet exposed. And then we have all sorts of other perimeters that we have internally. I don't even have time to get into it, but there are certain things that we can do to separate the internal perimeters as well from a VPC standpoint, with VPC peering, transit gateway, security groups, NACLs, et cetera, and so forth. Just a couple of things. I work for Ancestry.com, and so a lot of my experience, a lot of my presentation is kind of going to be focused from a web application perspective. And one of the things that you can do whenever you set up some sort of web application website is you can block your ingress into your account. You really, like we said, we only want trusted information into our account. One of the things that you can do is you can apply NACLs on your public subnets that say, hey, I'm only going to talk to my web application firewall. And then you're blocking at a lower level. You're not blocking at the security group, which is higher up on the stack. And you can basically say, hey, I'm only going to allow things that have been scrubbed through my web application firewall or whatever else you may have out there to protect your site. And you can prevent things that way. At the NACL level, you're a little bit more protected from a DDoS type of attack as well, because like you are lower down in the AWS hardware, just a little bit of information there. So we have the inbound taken care of, let's say, for example, but what about the outbound, right? Often when you apply an AWS security group, you look at the outbound rules, and they are always, the default is outbound to everywhere, right? And so you could have instances in your account that may initiate outbound calls to the internet. You know, how do you protect that perimeter? So one of the ways you can do, and this is just one thing you can do, is you can set up your routes, you can set up transit gateways. We're not going to go into that. But basically, I can set it up that all of the traffic that's originating from my account going outbound to the internet ends up at a network firewall somewhere. And then that network firewall, I can set up Suricata rules or whatever else you have that basically can say, I'm going to block connections to untrusted networks. I can block a TLS, I can block SSH, I can block SFTP, I can block a lot of those things using a network firewall. Right? So I've got my ingress and my egress completely covered, right? Well, not quite so fast, right? We control all the outbound traffic, right? Not quite so fast. What if something in my account goes, hey, I'm gonna make a call out to the internet. There's these things, I'm getting a little bit ahead of myself, apologize. There's these things called VPC endpoints, right? VPC endpoints, if I put them in my account, they basically create an AWS service to be a local call. So if I'm calling the S3 service, I'm calling it as a local connection. It's not going out through the internet. So we have a little bit of a hole here, right? So this traffic, since it's going through a VPC endpoint, it's not going to hit my network firewall. It's not going to be blocked by my security group. So what can I do? And that one of the things you can do is you can put a VPC endpoint policy on your networks that basically say, hey, I'm going to only allow S3 traffic out to trusted locations. And this just gives one very simple example. I have this resource account that says, hey, I'm only going to allow me to talk to buckets within my account, but I could also set that to be my organization, or I could also set up several other things, but this is just an example here. So we've covered all of that, right? So now we're covered, right? Well, not quite, because like we said, a lot of different AWS services have resource policies that are completely unattached to your VPC. Just to give an idea of what all of these are, you can look it up on AWS. Here's a link, but basically you can see resource-based policies, and if there's a yes there, this is something additional you have to worry about. So one example that like I said, there's lots there, but one example that I'll talk about is just API gateways. API gateways are basically an endpoint that can be publicly exposed. It's not attached to my VPC. I don't have security groups on it. How do I control that? Additionally, that API gateway may have a Lambda attached to it. That Lambda may have IAM permissions into my account. That's also going to be an issue. Is there authentication? Is there monitoring? I don't have any monitoring there unless I've set it up on my VPC endpoint. Also, that Lambda itself doesn't have to necessarily be attached to my VPC endpoint, or to my VPC. It can, I can configure it that way, but it could also make outbound connections. So, like I said, the devil's in the details. There's lots of nuances when you talk to the cloud. If you look at the API gateway policy itself, what's the default behavior? If you look at the decision tree, it comes in, is there a resource policy? No, you would think the default would be to block. But in the case with API gateway, it's allow everything, right? And so there's definitely another network boundary into your account that you have to worry about. We can fix that really easily by putting a policy on my API gateway. This one's a REST API gateway that basically says, hey, I'm gonna only allow traffic from my networks. This isn't a security group, but it kind of gets into that resource policy space. V2 API gateways are a little bit different, as AWS is. Nothing is consistent in AWS or in the cloud environments. And so V2, you may have to do other things like disable the API endpoint and other things. Like I said, there's lots of nuances. I can't go into other things. A couple other things that don't really come to mind when you're thinking about IP-based policies into your environment. If you've read any of the news for any sort of cloud environment, there's these things called API keys that basically give you the ability to do anything in the account from anywhere on the internet. And if you look at the default setting on those API keys, of course they're allowed from anywhere, by anyone, right? Anybody who has them. And there's also been plenty of stories like other AWS services like S3 buckets that have been publicly exposed. And again, that public exposure has led to issues or embarrassment for those organizations. So again, whenever we're thinking about resource-based policies, here are two really important ones that I'm calling out besides API Gateway that I can put on all of the keys that I grant access, that I can make sure that those are only allowed from trusted locations. Since we're talking about networks, I've given an example of IP addresses, but there's other things that you can do, like trusted accounts, trusted other things. But I can put a resource policy on my API keys. Same thing with my S3 buckets. I can put a policy, if it needs to be exposed, I can put a policy that only allows it from specific IP addresses, or in the case of a VPC, that it's only allowed from a VPC. Just two examples there. Another thing is there's some unicorn services in AWS that don't have resource policies, that don't have security groups associated with them. And these are yet another thing that you kind of have to worry about from a network perspective. AWS has a service called Transfer Service, which is SFTP. You may or you may not want to block who can reach that service. There's also the Cognito service, which is AWS's own identity provider. There's AppSync, there's CloudFront, there's other things here as well. A lot of these things, you don't have either one of those options. Some of these will work with the AWS WAF, and so you can put some network perimeter around those services as well. But the point is, there's lots of different ways of network exposure, public network exposure from an AWS account, and you have to take all of those into consideration. So next thing is permissions perimeter. So we're going to leave network alone. We're going to move on to permissions, right? In cloud accounts, everybody is going to need access, some level of access into your environment. That's just the way it works. Back in the old days, very few people got into your data center. The old data centers, you had very specific people. There was all sorts of control around that. We moved to the cloud, and we basically grant everybody access, more or less, or may need to access into our virtual data center. And so this is probably one of the more important perimeters that we need to think about in the cloud. There's many stories that have talked about people checking in access keys into GitHub or trust policies being weak or other things like that that causes all sorts of issues. The famous story that I always bring up is Cloud Spaces, who had access into their cloud account get leaked. Hackers got hold of it. They said, give us a bunch of money or we're going to shut you down. They said, we're not giving you any money, and they hit their automation script and it just started deleting stuff. And by the time they got it stopped, they're out of business. And so the permissions perimeter is a huge, huge important thing to worry about. But inside this, I want to break it down that there's several other permission perimeters that we've got to think about. It's not just access into our cloud, but we need to think about how we're going to allow humans into our environment, how we're going to do our deployment perimeter, how we're going to do deployment, and how we're going to separate that from the human, right? And then also the service roles, which is like once we're up and running, those service roles, how are those perimeters need to be managed well inside of our cloud account. So first of all, human access. So a couple of ideas when it comes to human access into your cloud accounts, right? My take on this is anybody that's going to have access into a stage or a production environment should be read-only at most. And I may even want to control what read-only access they have, right? The other thing I want to make sure is that they are limited time specific, right? They're not permanently granted access, and so I can use like the STS service to use only temporary tokens so that I don't have to worry about access keys getting leaked out. The other thing that I think is really important is role chaining. We'll talk a lot about this a little bit, but role chaining is a big risk within the permissions perimeter that we've got to worry about. I think another good practice is when you're talking about creating roles or users or other things that you name them with a specific start-off string, like a user dash or something else like that. So when you get into some of the more advanced topics like service control policies or IAM-based policies, you can use that to determine between if it's a human user or something else. Other important human perimeters here at this level, I won't talk about it that much, is administration roles. Really assuming if everything went bad and if you had one of your administrators have their laptop get compromised or their permissions get compromised, right? A good thing to think about is our cloud environment still safe? And so I like the idea of taking a ring zero approach that says, hey, if we had some sort of compromise, that those 80 credentials aren't going to be a weak point in our environment. So we'll leave humans alone and we'll talk about IAC deployments. I think a critical thing is the goal is I don't want humans to be able to do anything in my production environment besides see things, right? And a big crucial point of that is I have to have a really strong IAC deployment permissions perimeter, right? So this is going to be what's going to be allowed to deploy things into my accounts. I think this is probably one of the crown jewels, if you will, of your environment, right? That's really critical to protect your deployment pipelines into your accounts, because if those get compromised, those have all the permissions to create things, delete things, do things, all that sort of thing. You may want to separate your deployment infrastructure between different types of trust in your accounts, like a high trust, like a PCI account versus a corporate account versus something else. So these are all perimeters that are all things to think about in your IAC deployment perimeter. There's lots of things here that can go on. The other thing that I think we're going to talk a lot about here is the deployment pipeline is one of the places where we can put something, what I like to say is security gates, things that I can do in this permissions perimeter that can block risky things from being introduced into my accounts. So things like blocking public exposure, we talked about that, all the different ways that can occur just previously. Any sort of escalation of privileges, that's a big risk. Unauthorized services or regions, over-provisioned resources that have too many permissions or they're granted resource star. And then the last permissions perimeter, so we'll leave that one behind for a bit. The last one is the services access. So this is your steady state, what's running, right? And it's really important as we talk about our permissions perimeter. These are, a lot of times you may have a dev environment, a stage environment, a production environment. And those permission perimeters should be separated from each one of those, I guess you could say, stages or environments. And another thing you want to do is make sure that those permissions, what are running steady state, that they're not provisioned to have access to all resources. The other thing is, we're not going to talk about it a lot, I'll just mention it here, is IMDS v2. All of those services are going to run with permissions. Those permissions, let's say if I have a website, my website has a weakness vulnerability, someone finds a ways to go in and dump the temporary credentials from that service and be able to access them and run those, right? If they pull those out and they try to run them and they try to test whatever they can with those permissions, they can't do that if I've set up IMDS and I've set like the hop count. That's a specific thing to be 1 or 2. It says, basically AWS says, I'm sorry, that's not being called from the account. It's not going to be allowed. So there's lots of things to think about here, and there's more that I could add, but these are maybe the top 3. So a couple of things about breaking the permission perimeter. So, and we'll talk about how we go about protecting that. So IAM trust policies, here's one thing, right? If you go look at your AWS accounts, every role has a trust policy associated with it. In this case, I have a trust policy and I have an account 333-444 and :root, right? And what that essentially says is any role in this account can use the permissions associated with this policy. Well, do we know what that account is? Do we know what the role can do? This is something very, very important to watch, right? If something like this were to show up in your trust policy. Also, another thing, developers are very crafty people, I would say. They may do things that say, hey, I may get into a situation where I may need to jump in and be able to debug my code. I'm in a tight situation, I may need to debug my code. And so you may see things like chain roles showing up in your trust policies that basically say, I'm only going to use this for break glass, but I'm going to jump between different roles until I finally get into the role that I want, and then I now have permissions to do that. So there's 2 good examples of how this permission perimeter can be, one of those permission perimeters can be broken. Here's the example of what I'm talking about. Role chaining is I start out in a boundary account, I go to my development account, and then I switch over and I assume role into my production account. So that's the type of thing I'm talking about. Other things that can show up in policies that break these perimeters is, there are several different ways you can escalate privileges within AWS. One of the common ways is IAM pass role with resource star. What that basically says is, hey, I trust this role to start up another service like a Lambda or an EC2, and then pass it any role that is available within that account. And that's another thing that breaks that permission perimeter boundary. There's lots of other things like attach a role policy, create user, create role. There's a whole bunch of things. I can't list them all here in the time given, but I've got some links to those as well. And then another one that I'm not going to go into a whole lot, but confused deputy. This has been another problem where essentially I have a role, that role trusts an account, that account also has other accounts attached to it that are not trusted by me, but there's a way using the confused deputy attack where a role in a completely untrusted account can basically assume a role in my account using the confused deputy attack. I don't have time to go into it here, but I've got a link to that as well. Again, another way that our permission perimeter can be broken. And then we talked about unmanaged services, right? Managing your identity providers as well. AWS Cognito can do what? This is my slide here. Let's say AWS Cognito is, again, it's AWS's identity provider, right? And there are certain ways that you can set it up to have its own identities associated with it. And then you can look and you can set up the trust policies within your account to trust that Cognito identity provider. So there's another way that this permission boundary can be broken, is if I have unmanaged services like Cognito that are allowing people to authenticate to my account, and those authentications can then assume roles into my account as well. So fixing the permissions perimeter. Making sure that our identity provider that we use to get into our cloud is not public. I think all these things are no-brainers, right? That you can only access our API, the APIs in our cloud account or the console in our cloud account from a trusted network. That it requires multi-factor authentication, to get to that point, And then any sort of access there is time-bound. API access keys, I think they're the devil. They should be avoided. Unfortunately, sometimes those need to exist. And then we talked about trust policies. We talked about assume role trust policies, but you can also put other identity providers into those trust policies, and so that's something to monitor, looking for cognito or other types of things showing up in those trust policies. All right. So let's talk about some ways that we can control some of these permission perimeters. Don't have a lot of time to go into them, but there's things called service control policies in AWS. These are things that I can set up at my organizational level, and I can block certain high-risk things from being introduced into my environment to help protect those perimeters. Recently, AWS announced resource control policies, which are more tied to the resource, but those can put boundaries in place as well. And then the other thing that we're going to talk about is those, like I talked about, the deployment pipelines. It's very important to have deployment controls in there that can block some of the high-risk issues. Some example of service control policies that I can do, like I said, I'm not going to go into the details, but I can block unapproved services, unapproved regions. I can block DNS changes. That may be a real big issue that I need to control. I can block the creation of resources in public networks. I can block some escalation of privilege actions. I can block creation of access keys, et cetera, and so forth. I can block changes to any of the network infrastructure we talked previously. Security gate rules in our deployment control. A lot of times we use CloudFormation template or we use Terraform to deploy those. In our deployment pipelines, we have quality gates. We should be building in security gates as well. And some simple security gates that I can put into place. Here are just some high-level ones that we can put into place to block some of these, to prevent some of these boundaries from being broken. And I'm not going to have to go through all of those, but those are an example. All right, let's do a time check. Okay, I'm running out of time here quickly. So resource perimeter. We've talked a little bit about this. A poorly implemented resource perimeter could create a public exposure. We've talked about that. Roles should not be able to create external resources. There's two things to worry about here. Some resources are protected by a resource policy, but as you can see, there's a whole lot of no's selected in that column. And so resource level permissions are done in IAM policies. Those we may have to put protections in IAM policies. The problem with those IAM policies or role policies is you can do a really good job with IAM roles, and then one role, and everything's least privilege, and then one role gets in there and it's full privilege and it has access to the resources. So that's a little bit difficult. So breaking the resource perimeter, a resource policy, put on, in this case, a SQS, a queue service that basically is granting anybody authenticated to AWS to fully manage my queue. I call this a resource perimeter violation. I can create a role that has a permission to do a dangerous action, like terminate instances with a resource star. All of a sudden, if this role has an issue or gets compromised, I can lose all of the compute within my account. Resource policies, we talked a lot about these, right? One of the things that you should do is turn on public access blocking at the organizational level that will make sure that all your S3 buckets are not publicly exposed. And that should cover you, right? Well, not quite. If somebody creates a resource policy that trusts a specific account, that maybe you don't know what it is, and maybe it's doing get object, here's a way that the resource perimeter is broken, right? I'm now allowing an untrusted account to get objects from this particular S3 bucket. This is a policy put on an S3 bucket. And the block public access didn't necessarily prevent this from happening. Fixing the resource perimeter, we talked a lot about this, right? Turning on public access blocking, resource control policies, we talked a little bit about that. And we talked about the security gate that can put standards on how resources can be configured, what things are allowed to be, what things are trusted to call the service, and what actions can be made as well. I mentioned this is new. Resource control policies do not cover everything. There's just 5 services: S3, STS, KMS, SQS, Secrets Manager. And again, here's some examples for some security gate rules to block that. All right, I am really short on time. So data perimeter is the most important perimeter. Essentially, this is looking at where is the critical data to your business that you need to know what to run. And we're going to go through all of those things that we just talked about: the network perimeter, the permissions perimeter, the resource perimeter, and make sure that all of those are in place and they're strong and that we don't have any weaknesses. They're in place. And then one last thought here on the data perimeter, right, is assuming we had a complete compromise, our data backups, all of our data, our critical data is protected, right? You know, answer that. AWS has a service called S3 Object Lock that I would recommend you looking into that can do those types of things, assuming if you do backups and you put them into S3, you can put an object lock on it that nobody can delete that, not even the root account can delete the resources. Knowing that where your data is half the battle. So in sort of closing, right, there's a lot of different nuances in the cloud. There's lots of ways things can go bad, they can be broken. There's lots of different perimeters to think about. And to quote Tolkien here, right, you have to assume that there's a dragon out there somewhere that's going to try to break into your account and do bad things to you, your organization, your coworkers, your teammates. So don't leave that out of your calculations. So thank you. Thanks for coming, and hope you had a great conference. Thank you. Thanks.